All right, this is 1.7 transformations of functions. I think this is a really key section here in chapter 1 to be able to solidify the big picture ideas so that no matter how ugly a function gets later on in pre-cal, if you can know these basic 10 transformations here, then you'll know the general idea of how a function changes. So hopefully you already have these 10 written down. If you don't, you can pause it, make sure you get all 10 of those. But we're going to go on and start using them and talking about how each one affects a function. So the first one on your homework is actually this, number 8, and they give you this graph. And if this looks different from yours, just go back and check, because this is the graph for number 8. And then it's asking you to do these 7 transformations to it. And some of them are very straightforward, to where, like, for instance, the first one, f of x minus 5. Well, this is a shift to the right of 5 units, because any change that happens inside the function, it always goes opposite. So since that's a minus 5 there, that means that's a shift to the right. So I'm just going to take all these points and move them over 5 units. Now, this is counting by 2's. So like this is 2, 4, 6, and 2, 4, 6. Negative 2, negative 4, negative 6, and so on and so forth. Now then, so if I'm moving it 5 units to the right, well, that would be 2, 4, 5, and then 2, 4, 5, 2, 4, 5, and 2, 4, 5. Because like that point right there would go from a negative 3 to a positive 2, and from a negative 6 to a negative 1. And so now I have this new function over here that is exactly the same as my first function, just shifted 5 to the right. And maybe not quite as pretty, but you guys understand the same idea, right? Try to do a little bit better job. There. Okay? Now then, next one. Negative f of x plus 3. Negative f of x plus 3 tells me that it's going to move up 3, since that's a plus 3, and then it is going to be reflected over the x-axis, or it's going to be flipped upside down. So this entire thing is going to go up 3, and then it's going to go upside down. So if I think about flipping this thing and moving it up 3, if I go up 3, and it doesn't matter whether you reflect first. So I'm going to go ahead and do that. Now, if I think about this being a negative 4, this point right here being a negative 4, then if I reflect that, well, that becomes a positive 4. And then if it goes up 3 from there, that means this point is now going to be up here at 7. And this one would 0, doesn't change, it just goes up 3, which would take me to 3. Up 3 to 3 there. This one goes to a negative 5 and then up 3, which would take me to a negative 2. And then this one here would mirror this one up here where it's also up at a 7. And so then I have the same function just upside down now. And moved up, right? So up 3 and upside down. Good? Now then, start to get more fun. Here with 1/3 f of x, that is going to be a vertical shrinking or a horizontal stretching. It's the same sort of idea, but we're going to think about it as a vertical shrink for this one, because each y value is going to be 1/3 of what it was. Now then, a few of the easy ones. The zeros aren't going to change, because 0 times 1/3 is still 0. But if I take this y value here, negative 4, and multiply it by 1/3, well, that moves me to a negative 4/3, which would be 1 1/3, right about there. If I take this value 5 and multiply it by 1/3, well, that's 5/3, which is almost up to 2. And then a negative 4 here is going to move up as well, up here to 1 1/3. And so now I have this short squatty function, right, that has been flattened out or sat on or compressed or shrunk vertically. Technically, horizontally, it's the same width as always. It's just been vertically shrunk. Good. Now then, the next one, good old negative f of x plus 1. Well, that's going to be reflected across the x-axis, just like the previous one that had a negative out there. And then it is going to be moved to the left, one value. So all of these numbers are going to get flipped and then moved to the left. So negative f of x plus 1 would be reflected. So negative 4 becomes a positive 4, and then it moves 1 to the left. So now, instead of being at a negative 6, that's now at a negative 7. And so on through there. So 0's still going to stay 0, but then move to the left. Positive 5 becomes a negative 5 and moves 1 to the left. This 0 over here moves 1 to the left. And then this last one, negative 4, becomes positive 4 and moves 1 to the left. And so now I have the function flipped over and moved over 1. That's getting so pretty with all those colors in there. Next one, f of negative x. Now, f of negative x means that it's going to be reflected across the y-axis. And I appreciate this one because it's already done for me. Because if I take this 6 here and flip it over to negative 6, well, it's right there. And the negative 6 over to 6, and it's already there as well. And so on with every single point, because this function that I'm reflecting across the y-axis has y-axis symmetry already. Therefore, it's the exact same function again, and it would be right on top of the previous function. Next one, that was nice and quick. F of x minus 10. Well, that means it's just the original function down 10. So I take the original function and move the entire thing down 10. So up here where I start at 5, well, that's at negative 5. And 0 is going to go down to a negative 10. So negative 8, negative 10, right? And 0 down to negative 10 over there. And then a negative 4 is going to go all the way down to a negative 14. So that can come all the way down to here, and that one all the way down to here. And so now I have the same function, just moved down 10 units. And then for my last one, final one, 1/3 x, y equals f of 1/3 x. Well, that is a horizontal shrink. Because again, that fraction means it's getting smaller. So all my x values, horizontal stretch. Horizontal stretch. And so that's going to stretch all of mine out 3 times as much. So like this negative 6 value is going to become a negative 18. So if I think about negative 10, negative 14, negative 18. So all the way out here is where that value's moved to. Because if I think about plugging it back in and going back to negative 6, that's a negative 18. Negative 18 times 1/3 is a negative 6. And it's almost like anything that happens inside the function is backwards. So that x value in there gets stretched all the way out. And same thing over here, this 6, right? 10, 14, 18 is going to get moved all the way out to here. So the 3 is going to get moved all the way out to 9, and the negative 3 is going to get moved all the way out to a negative 9. And then 0 doesn't get stretched, that's still 0. So now my function is all stretched out really wide, all the way out like this. And so you'll see it's just a horizontal stretch. It stretches the whole thing out horizontally. And really it looks like my yellow graph in here. The one that was the vertical shrinking, it looks like the same as the horizontal stretch, just larger, stretched out over a large period. So the fraction does the same visual kind of thing to it, just in a very different manner. All right, that's number 8, and that is a recap of all of the rules of vertical, horizontal movement, reflecting, and then also stretching and shrinking. Next video, I'm just going to do a bunch of examples of different types of problems that you're going to have on like the 19 through 27 odd problems.